we're going to discuss sections 2.3 and 2.4 all together as one big section. The homework in my lab math is all together in one big section, and this all works because it really is all about linear functions and slope. So down here we have three lines: y equal 1/2 x, y equals 6x, and y equal x. And if I had a colored printer, they would be in different colors, but I don't have a colored printer, so we'll highlight them. And in green here, there is y equal 1/2 x. In blue, right there, we've got y equal x, which is the same thing as 1x. And then how about red? Right there. There's y equals 6x. You can see they're all lines. And what is the difference between each one of the lines is how tilted they are or how steep they are. That concept of steepness or tiltedness, if you will, is called slope. And we see that as the number, the coefficient in front of the x, the 1/2, the 1, as those numbers get bigger, the line gets more tilted. That is the concept of slope, how tilted, how steep a line is. And that's what we have here. It says they are all the same except for how fast the line rises from left to right. The concept of how fast a line rises or falls, or how tilted a line is, or how steep, is the concept of slope. All those lines are said to have a positive slope because as we trace them from left to right, the line rises. Positive slope lines rise as we travel from left to right. A line that falls from left to right has a negative slope. Then a horizontal slope has a slope of 0. And that makes perfect sense if you think about slope being a measure of how tilted, how steep a line is. A tilted line has no, or a horizontal line has no tilt. It has 0 tilt. A horizontal line has no steepness. It has 0 steepness. So the slope of a horizontal line is 0. And a vertical line is said to have an undefined slope. And that makes sense too. A vertical line is the ultimate in steepness. It's as steep as you're going to get. It's the ultimate in tiltedness. I don't think tiltedness is a word, but we'll go with it. Vertical line is the ultimate in tiltedness, the ultimate in steepness. So they are the most steep. The vertical line is the most steep, the most tilted you could get. And so we want a number that describes the biggest it could possibly be. Well, there is no biggest number. Infinity is not a number. Infinity is a concept of growing without bound. Slope is a number. And so because there's not a biggest number, there isn't an adequate way to describe the steepest thing ever, the most tilted thing ever. There's not a biggest number, so there can't be a slope, so we say it's undefined. Here's my formula for slope. The slope of the line passing through 2 points, x sub 1, y sub 1, and x sub 2, y sub 2, is given by m equals the quantity y2 minus y1 divided by the quantity x2 minus x1. You should memorize this. First use of whiteout today. Memorize. Now here we have it as y2 minus y1 over x2 minus x1. You can permute that subtraction. It can be y1 minus y2, as long as the denominator is x1 minus x2. So example 1 here, find the slope of the line passed through each pair of points or state that the slope is undefined. Then indicate whether the line through the points rises, falls, or is horizontal or vertical. So we will just start by using our formula. If it helps you, label your points. And slope is y2 minus y1 divided by the quantity x2 minus x1. And so we have negative 4 minus 6 over 2 minus 2, which is negative 10 over 0. And then you need to get this right. Division by 0 is undefined, and so this is undefined. And so that makes it vertical. Undefined slope means vertical. Now, if you forget, because students forget all the time, okay, that 0 in the denominator, does that make the answer 0? Does that make the answer undefined? If you forget, just take your calculator out and do it. We have negative 10 divided by 0, and it will happily tell you error division by 0. If you forget, and there's no shame in forgetting, ask your calculator. Now, we already know that it's vertical, but let's just verify that it's vertical. We have the point 2, 6. So there's 2, there's 6 right about there. We have the point 2, negative 4, looks like it's right there. And if I connect the 2 points, indeed, it's vertical. Okay, more of the same. Okay, do each one of these problems really the exact same way. If you need to, x1, y1, x2, y2. So m is y2 minus y1 over x2 minus x1. And let's see what we get. Negative 5 minus 6 over 2 minus 3, which is negative 11 over negative 1, which is 11, which is positive. And so the line rises. Things with positive slope, or lines, not things, positive slope lines rise. Just going to write that a little neater. Positive, so we rise. And then just to verify it, 3, 6 looks like it's roughly, I know this is a really small grids. 1, 2, 3, 4, 5, 6. 3, 6 looks like it's right about there. 2, negative 5 looks like it's right about there. I think I have that off a little bit, but that's not the point. And though it seems like it's almost vertical, it's not. It's rising. Now, I missed my point there a little bit. When you miss your point just a little bit, just make your point bigger. And it is rising. Do it again. x2. I could label them x2, y2. Doesn't matter, but we'll go in order. x1, y1, x2, y2. And so m equals y2 minus y1 over x2 minus x1. And so that's negative 8 minus 5, yep, and 5 minus 2, which is negative 13 over 3. Leave it like that. Don't tell me what decimal that equals. I do not care what decimal that is. That's negative, so we know that the line has to fall. And then just verifying that again, 5, negative 8, looks like it's right about there. 2, 5, looks like it's right about there. We connect those points, and indeed, we do see that the line is falling as we travel from left to right. When we talk about rising and falling, it's always as you trace the line from left to right. And one more time, x1, y1, x2, y2. And so m is y2 minus y1 over x2 minus x1. So 6 minus 6, 7 minus 4, 0 over 3, which is 0. And again, I can't remember which one it is. take out your calculator. 0 divided by 3. It happily tells me the answer is 0. And so that makes it horizontal. Lines with a slope of 0 are horizontal. And if we verify that, 4, -6 looks about right there. 7, -6 looks right about there. We connect the dots, and indeed it is horizontal. So there's our first thing about slope. Positive slope lines rise left to right, negative slope lines fall left to right, vertical lines undefined slopes, horizontal lines 0 slope. So moving on a little bit, we've got the slope-intercept form of the line. So I have right here in front of us y equal 2/5 x plus 1. If I asked you to graph it, we could do a table of values, a t-chart. It would look something like that, and then we would get the graph that looks something like that. We can see from the graph right here that there's my y-intercept. It's the point 0, 1, or 1. That looks like a minus sign. It's a comma, it's not a minus sign. 0, 1, or if you want, just 1. Being real specific, it's a point. There's a 1 in the graph, in the equation too. Not a coincidence. That when I am in this form, y equals what's going to be called momentarily mx plus b. When I'm in this form, that constant on the end is always the y-intercept. So there's one thing to notice. So the next thing I have here is calculate the slope. So using those points above, from the chart above, we will use the points, and it doesn't matter which points I pick. I'm just going to pick the first two, -5, -1, 0, 1. So there's x1, y1, x2, y2. And so my slope, using my formula for slope one more time, which you absolutely need to memorize, would be 1 minus -1, 0 minus -5. Yep, that's right. Or that's 2/5. Well, there's a 2/5 in the problem, too. Again, not a coincidence. It's all because when I'm in this form, which is called slope-intercept, y equals mx plus b is a line with slope m and y-intercept 0b or just b. That anytime I'm in that form, you automatically know what the slope and intercept are. The slope is the coefficient of the x, and it's just the number, not the x, and the y-intercept is just the number on the end. So let's work with that a little bit. For each of the following, find the slope and y-intercept. And when you read those instructions, that means use y equals mx plus b. So in this first problem, just immediate. My slope will be m equals 4, and my y-intercept would be -14, or if you're being a really precise mathematician, 0, -14. I believe the computer just asked you for that. For me, on a test or quiz, either one. Let's do this last one really quickly. I could easily rewrite that equation, rewrite that one in that form, being very explicit, y equals 1x plus 0. Then my slope immediately is m equal 1, and my y-intercept is 0, or the point 0, 0. Remember when we talk about intercepts, the other coordinate is always 0. So in the y-intercept, the other coordinate x is always 0. We'll conclude this video and start up with the next ones momentarily.